Hello everyone. Hello everyone. Am I audible? Okay. So welcome back to my channel Anis Sir's Technology. In this session, we are going to discuss a very frequently asked question in the examination. 4 into 4 matrix. In the 4 into 4 matrix or any order of matrix, print the sum of left and right diagonal. Okay. So before starting the coding part, let's discuss what exactly the left diagonal, what exactly the right diagonal. This is the left diagonal and this is the right diagonal. Left diagonal is also called primary diagonal or the main diagonal. Right diagonal is called secondary diagonal. Okay. Okay. So just a moment. See, I'm going to draw a matrix of 4 into 4. Just I'm defining a matrix in a diagrammatic way. Then you will better understand what is the logic of the left and right diagonal. Okay. So first of all, int and 2 square bracket is equal to new. Then int and we have to specified row and column. All right. In this manner, we can construct a double dimension array. Okay, sometimes students complain that my voice is coming in intermittently. So if is there any kind of this issue, please let me know. So this is a array declaration, double dimension array declaration. After that, the construction of the matrix will be start in the memory like that. Allow me 1 minute. Then I will definitely come to the programming part. How many rows will be there? This is row. This is column. 4 into 4. In the previous lecture, I have already told all kinds of diagonal related question are only based on the square matrix. So I've taken a square matrix. Okay. 1 second. Okay. These are the 4 rows. 1, 2, 3, 4. 1, 2, 3, 4. Now we have to construct the column. 1 column, 2 column, 3 column, and 4 column. Okay. And after that, we have to assign every cell by the index number. Just 1 second. This is 0. This is 0 row, 0 column. Okay. 0 row, 1 column. 0 row, 2 column. 0 row, 3 column. Similarly, 1 row, 0 column. 1 row, 1 column. 1 row, 2 column. 1 row, 3 column. 2 row, 0 column. 2 row, 1 column. 2 row, 2 column. And 2 row, 3 column. And 2 row, 4 column. Just a moment. 1 second. 3 row, 0 column. 3 row, 1 column. 3 row, 2 column. And 3 row, 3 column. Perfect. Perfect. Now we have to place some number. Okay. These are the number stored in cell. It can be of any number, not an issue. I'm taking some serial order number, or we can say that natural number. It can be of any number input by the user. Now, what is left diagonal and what is right diagonal? Just 1 second. This is left diagonal. This is left diagonal. Or we can say that this is the primary diagonal. Okay. And what about the right diagonal? This is a right diagonal. Now, we have to observe one thing very important. In the left diagonal or in the right diagonal? C. In the left diagonal, row and column are absolutely same. When the row and column number is same, this is the position of left diagonal. See 0, 0, 1, 1, 2, 2, 3, 3. Apart from these left diagonal elements, there will be no any other element which will get the row and column same. Okay, we can check. हम check कर सकते हैं. See, this is row and column is not same. This is the row and column is not same. This is the row and column is not same. Row is 0 and column is 2. Row is 0 and column is 1. And row is 2 and column is 3. So when the row and column is same, definitely it will be a left diagonal. LD stand for left diagonal. So in the left diagonal, condition is very simple. If row and column are same, this is the position of left diagonal. Now what about the right diagonal? See, this is the universal logic. Any kind of matrix, any order of matrix, like 100 cross 100, this logic is not going to be changed of the left diagonal. Row and column are same. 1000 cross 1000, this logic is not going to be changed of the left diagonal. Row and column are same. If the row and column are same, these are the position of left diagonal. Now what about the right diagonal? Let me check. When the row and column sum 0 plus 3, 0 plus 3 is 3. 1 plus 2, 1 plus 2 is 3. 2 plus 1 is 3. 3 plus 0 is 3. Okay. When the row and column sum, when the R plus C, when the R plus C is equal to 3, these are the position of the right diagonal. But this is not the universal logic. It depends upon the order of the matrix. If 4 cross 4, then row and column sum will be 3. Always the matrix order -1. Okay, what I'm trying to say, if 4 cross 4 matrix, what is the condition of right diagonal? R plus C double equal to 3. But this condition will only be applicable for the order of 4 cross 4. When the matrix order will be 5 cross 5, this condition will be slightly changed. R plus C double equal to 4. Okay. So I'm going to write the generalized formula. So generalized formula of the right diagonal will be R plus C double equal to matrix order matrix order -1. Okay, hope you understand. But the left diagonal logic will be always same, R double equal to C. Now we can go for the programming. We understood the logic of the left and right diagonal. Okay, when the row and columns are same, these are the position of the left diagonal. When the row plus C is equal to matrix order -1, it is the position of the right diagonal. Okay, now let me change the screen. Okay. So my question is, write a program to input 4 into 4 matrix and print the sum of left and right diagonal. After printing the matrix, okay, I will print the matrix also. Just 1 minute. Here, I'm writing a program, left and right diagonal. Just copy it. Okay, double click and remove all these codes. It is not needed. Class, left and right diagonal. Okay. Public static void main string args. These are the basic steps. Scanner ob is equal to new scanner and system.in. Okay. Matrix declaration, square bracket is equal to new int 4 and then 4. Okay. I'm just writing the question over here. I think it's copied. Oh no, it's not copied. 1 second. Let me copy. Let me copy the question. Okay. Now we can paste it. Okay, fine. And I will make it comment. Okay. So this is the question and I'm going to write the right solution. Okay. We have to take R and C, R for row and C for column. So first loop will be always cover the row. R is equal to 0, R less than equal to 3 and R plus plus. Then for C is equal to 0 and C less than equal to 3 and C plus plus. Okay. Now for input, we have to write system enter element of matrix and n of R C is equal to ob dot next int. Okay. So the matrix will be open. Matrix will be input. Now we can print the matrix which is input by the user. So I'm writing a simple line print ln matrix display and I'm copying this first two loops and pasting here for printing the entire matrix for saving the time. Only for printing the matrix, we have to print system.out.print and n of RC plus little space. So the element will not be congested. And system.out.println. So after printing the element of first row, after printing the element of first column, the row will be changed. The line will be changed or the line will be break. Okay. So the matrix format will be developed. Now, now we have to write the actual logic of the left and right diagonal. We can write the logic. We can write the logic in this loop also. But before that, we have to take the two variable. LD stand for left diagonal and RD stand for right diagonal. Okay, here we can write a condition if R double equal to T. Okay, means when the row and column will be same. When the row and column will be same, then LD is equal to LD plus N of RC. This is condition of left diagonal. Now, what is the condition of right diagonal? If R plus C double equal to matrix order minus 1. So what is the matrix order? Sir, the matrix order is 4 cross 4. So R plus C will be equal to 3. And RD is equal to RD plus N of RC. Okay, this is the condition of right diagonal. Okay, now we can print. So this is the matrix printing, and after that, we can print sum of left diagonal plus LD and sum of right diagonal plus RD. Okay, let me check the alignment, and we have to use system.out.println. So in a separate line, the output will come. That's fine. Okay, one package is missing because the scanner class comes under java.util.asterisk. Java.util.asterisk. Let me compile. There is no error. This is the matrix input part. This is the matrix printing part. And simultaneously, we are also calculating the sum of left and right diagonal. If we don't do this part over here, then we again have to write a separate for loop for row and column. Then we have to write this part in that loop. Unnecessary, the program will get lengthy. Okay, just a moment. Let me run this program and see the proper output. Right click, inputting the matrix. Inputting the matrix. Just 1 second. See, the program is asking the elements. So I'm giving the small elements for simple calculation. 1, 2, 3, 4, 5, 3, 2, 1, 3, 4, 8, 4, 3, 2, 1, 2. Okay. Let me check. Let me check. Just give me 1 minute. I'm just marking. Okay. See, this is left diagonal. So what is the calculation of the left diagonal? 8 plus 2, 10. First, I'm writing the left diagonal element. 1 plus 3 plus 8 plus 2. So 3 plus 1, 4. 4 plus 8, 12. 12 plus 2 is equal to 14. Absolutely correct. So left diagonal summation is absolutely correct. Now I want to check the right diagonal. This is a right diagonal. So what are the right diagonal element? 4 plus 2 plus 4 plus 3. So 4 plus 4, 8 or 2, 10. 10 plus 3 is equal to 13. Absolutely fine. So the perfect output is coming as per the logic we have discussed. Now, wait for a second. Wait for a second. Let me clear all this screen. And coming back to the programming part, programming window. This is programming window. And I'm changing the order of the matrix. Okay, just I'm taking 3 cross 3, 3 and 3. Okay, so what will be the basic changes we have to do? First of all, the loop will be execute. The loop will be executed the row till 2. ये 2 तक चलेगा. And this also has to be go on 2. ये भी 2 तक जाएगा. Okay, similarly, ये 2 तक. This is also up to the 2. Now, this condition is not going to be changed. Only this condition will be changed. So the matrix order is 3 cross 3. I'm writing the matrix order. Matrix order is 3 cross 3. So the right diagonal logic will be R plus C is equal to 2. Perfect. Now I'm going to write this will be 2. And let me clear all this. And again, I'm executing the same program. Just 1 second. Right click. Now the element will be lesser. How many total elements will be there? Total 9. So 1, 2, 3, 4, 5, 6, 7, 8, and 9. That's it. Now we can check. What about the left and right diagonal sum? See, this is left diagonal. 1 plus 5 plus 9 is equal to 15. Okay, perfect. What about the right diagonal? And 3 plus 5 plus 7. It's simply a coincidence. 7 plus 3, 10 plus 5, 15. Perfect. Okay. Now I'm sure you understood and you can develop these kinds of program. In the next upcoming lecture, we will discuss the another question of the matrix. Thanks to all of you. If you have any doubt, apprehension, confusion, you can post your query.